Hi guys, welcome back. So what we're looking at today is lesson 11, using equations to solve problems. So let's go ahead and jump right in. So at the fair, Tyler is making invitations to the fair. He's already made some of the invitations and he wants to finish the rest of them within a week. He is trying to spread out the remaining work to make the same number of invitations each day. Tyler draws a diagram to represent the situation. So what we want to do is explain how each part of the situation is represented in Tyler's diagram. So how many total invitations is Tyler trying to make? Well, if we look at our tape diagram here, what's our total? 122. So he's trying to make 122 invitations. How many invitations has he already made? Well, if we're going to take and look for how many he has left that he wants to divide evenly, we look to the number that's not our variable. So he's already made 66 invitations. And how many days does he have to finish these invitations? So if we look, how many X's do we have? So 1, 2, 3, 4, 5, 6, 7. So we have 7 X's, so he has 7 days to get these invitations completed. So for part B, how many invitations should Tyler make each day to finish his goal within a week? So we know he has 122 invitations he has to do total. And that equals his 7x plus 66. So if we subtract the 66 from both sides that he's already done, we have 7x equals 56. So then the next thing we need to do is divide by 7 to find out how much he has to do each day. And we end up with 8. So he has to do 8 invitations a day to take and finish his goal. So for part C, use Tyler's diagram to write an equation that represents the situation. Explain how each part of the situation is represented in your equation. So we already wrote the equation. We have the 122 equals 7x plus 66. So the same amount, so I'm going to explain this rather than write it out because there's not a lot of space. So he makes the same amount, x, for each of the 7 days. So that's how we got the 7x, because there's 7 days where he's making the same amount of invitations. So there's our 7x. Then he's already made 66 invitations. So that's why we have that next box there with the 7x's to represent those that he's already completed. And then our number at the top, representing our total, is how many he needs to have done. So that represents how many total, including the 66 and each that he does in those 7 days, that he will make. So part D, So we essentially did part C and D over here for part B. So this is how we would solve. We'd start by subtracting the 66 from both sides. Then we'd divide by 7 to find that our solution is 8. All right, for number 2. Noah and his sister are making prize bags for a game at the fair. Noah is putting 7 pencil erasers in each bag. His sister is putting in some number of stickers. After filling 3 of the bags, they have used a total of 57 items. Explain how the diagram represents the situation. So we can see the total, 57 items across the top. We can see the 7 erasers that are going in each bag. And it says that there's 3 bags, so there's 3 7s there. And then we have the 3 X values to represent the stickers that his sister's putting in each of those 3 bags as well. Remember, it says they filled 3 bags. So for part B, Noah writes the equation 3 times the quantity x plus 7 equals 57 to represent the situation. Do you agree with him? Yes, we should agree with him. There are 3 groups of the x plus 7, and then they total the 57. So yes, we agree. 3 groups of x plus 7 equals 57 total items. All right, so for C, how many stickers is Noah sister putting in each prize bag. So we're going to solve this equation. So we have 3 times x plus 7 equals 57. So if we take, there's different ways that we can take and do this. So we could divide first by the 3, or we can take and distribute first. Either will work. I'm going to go ahead and divide first. So if we divide this by 3 and by 3, we end up with x plus 7 equals, now 3 can go into 5 one time with 2 left over, so then 3 can go into 27 9 times, so we end up with 19. And then to finish solving, we subtract 7. So x equals 19 minus 7 is 12. So 12 stickers in each of those bags. All right, number 3, a family of 6 is going to the fair. They have a coupon for $1.50 off each ticket. If they pay $46.50 for all their tickets, how much does a ticket cost without the coupon? Explain or show your reasoning. If you get stuck, consider drawing a tape diagram. Oh, sorry. Okay, so if we look at this, we have 6 tickets being sold. They paid $46.50, but they got $1.50 off for each ticket that they sold. So one way to take and try and find the cost for these tickets is start by dividing the total price by how many people there were. So taking the $46.50 and dividing it by 6. So if we do that, we're going to find that it's $7.75. So that's what they paid for each of the tickets they purchased. Now, they had the coupon. So that means we have to add $1.50 to find out what the original cost was. So if we add $1.50, we're going to get $9.25. So there's our solution. So hopefully that's making some sense and not too confusing. We could have wrote an equation for this. So knowing that the total was the $46.50 and then equals, we knew there were 6 tickets sold, some original value minus $1.50. So that could have been an equation we used to help us in solving this and help us see the situation a little better. All right, next section. Running around. Priya, Han, and Elena are members of the running club at school. Priya was busy studying this week and ran 7 fewer miles than last week. She ran 9 times as far as Elena ran this week. Elena only had time to run 4 miles this week. How many miles did Priya run last week? So obviously we know she ran fewer. So it tells us Priya ran 9 times as far as Elena. So we're going to take the 9 times 4. Because Elena ran 4 miles this week, and 9 times 4 is going to give us 36 miles. Now, it says that she ran 7 fewer miles than she did last week. So if we want to know how many she ran last week, since this week she ran 36, we're going to take and add 7 to 36. And so we'll end up with 43 miles. All right, for B, Elena wrote the equation 1/9 times the quantity x minus 7 equals 4 to describe the situation. She solved the equation by multiplying each side by 9 and then adding 7 to each side. How does her solution compare to the way you found Priya's miles? So what did she do? She multiplied by 9 first, then she added 7. She took and wrote an equation to do it. We worked it backwards. So Elena solved an equation. So Elena solved an equation, we worked it backwards. All right, number 2. One day last week, 6 teachers joined 5/7 of the members of the running club in an after-school run. Priya counted a total of 31 people running that day. How many members does the running club have? So we know there were 5/7 of the running club. So X represents the number of people in the running club. We have 5/7 of them plus the 6 teachers who joined equals a total of 31. So if we take and subtract 6 from 31, we're going to get 5/7 X equals 25. Then we'll divide by 5/7, divide by 5/7. And so remember, if we're dividing with a fraction, it's the same as multiplying. So we're going to take and multiply 25 by 7/5, and we're going to end up with 35 members. So always remember your same times flip. All right, for number 3, Priya and Han plan a fundraiser for the running club. They begin with a balance of negative $80 because of expenses. In the first hour of the fundraiser, they collect equal donations from 9 parents, which brings their balance to negative $44. How much did each parent give? So we know they started with the negative $80. They added 9x, because we don't know how much the parents gave, but we know 9 parents gave equal donations, and it equals negative 44. So to solve this, we're going to add 88 to both sides. So we end up with 9x equals, if we add 80 to negative 44, that's going to take and give us 36. And then divide by 9, divide by 9. So X equals 4. So they got $4 from each of those parents. All right. For the last one, let me move this up here so you guys can still see. The running club uses the money raised to pay for a trip to a canyon. At one point during a run in the canyon, the students are at an elevation of 128 feet. After descending at a rate of 50 feet per minute, they reached an elevation of negative 472 feet. How long did the descent take? So we know they started at 128. They descended at a rate of 50 feet per minute for some amount of time. So that's where a variable goes. And it equals negative 472. So if we solve this out, we're going to start by subtracting the 128 minus 128, negative 50x equals, so we have negative 128 being, we have negative 472 and we're subtracting negative 128. So we're going to end up with $600. And if we divide both, that's negative 600. Divide both sides by negative 50, then we end up with X equals 12 minutes. So all of these are about being able to read through that word problem and figure out how to write the equation, how to best represent the situation to be able to solve for your variable. Your keyword for this lesson is word problem. Word problem is your keyword for this lesson, since we looked at a lot of word problems and being able to pick out that necessary information and know what needs to be added or subtracted, what it should be equal to, what the coefficient is on our variable, so what needs to be multiplied there. So really keep track of what's going on in your equations and make sure you know where it belongs, okay? If you guys have any questions, feel free to ask. Have a great day. Bye, guys.